So here we are. Good morning, everybody, here and everywhere else. So today we start introducing the topics for this course. Okay, and then we're going to talk about software and software engineering. Okay, the course is about design, but design is an important phase of the software engineering process. Then we need to understand how to place design in the bigger picture. Okay, and the bigger picture is the software engineering process. So let me start with the simple goal of software development. So when we develop software, our goal is to build software that creates value, okay? And value is the functionality provided by the software that we want to create and the quality, okay? It's a very simple goal, isn't it? So we want to build a software with quality. So the question is, if the goal is so simple, why achieving this goal is so difficult? Okay, there are many different reasons, but most of them relies in the inherent nature of software. Okay, software is intangible. It's very hard to understand what is the development effort that we need to put in creating the software. I mean, it's not like producing an object. So we cannot touch it. Then it's very difficult to understand if it's big and heavy. Okay, you might have any idea that is very difficult. But with software, it's quite difficult to understand what's the real effort that we need to put in this. And software is very easy to reproduce. Okay, once you have your software built, just copy paste and you can create thousands, millions of different copies for the same software. Okay, in a snap. In other engineering disciplines, the manufacturing is the costly stage. I mean, think about a car. You can easily design a car, but then the most expensive phase is the manufacturing of the car. With software, it's completely different. So the hard phase is the design and development of the software. Then the production of the software is quite easy. We cannot automate it, unfortunately, or likely for us, as we are a developer. If we have artificial intelligence that work and make software, it's a problem for us. Okay, and it's very hard to automate. There are some tools, I guess you know, helping us in some activities, but the most important activities are human activities. For example, the design part that we will discuss in this course. No way for automating this. And there are other reasons. I mean, nowadays everybody can get a course on Coursera or on YouTube or whatever, and they think they are programmers. Okay, so coding is not the issue anymore. Okay, everybody can hack something together and then and run the software. But quality is much more than coding. Okay, producing a software is much more than just coding, and that's the primary reason because we don't have quality in our software. More software is very easy to modify. Okay, just download the source code of the software, then make a change in only one line of the entire software, and then you have a new software. Okay, working, not working, that's another problem. But what I mean is it's very easy to modify, edit, and create software out of other software. And the problem is that most of the time people make changes to this software without understanding it. Okay, and that, well, this is quite important, as we will see and discuss later. Most of the development projects in the real world is maintenance. Okay, so it's very hard, it's very difficult to get working in get a new job and you start developing a new software from scratch. Most of the projects out there are maintenance or refactoring projects. Okay, so we should get used to work on software written by someone else. And software doesn't wear out. It deteriorates only because the design change. And the design change for many different reasons. Because there are bugs in the actual version of the software and then we have to fix the bugs. Or because we need to evolve the software because the requirements for the software are changed. For example, a new function, we want to add the new functionalities, or we want to modify a given functionality already existing. Okay, and this make this task very very complex if we are not anticipated this change. So the software that we want to produce should be ready to be changed, okay, or flexible. Okay, we should anticipate this need because we will have these needs for sure, sooner or later. The demand of software is very high in raising. Okay, I mean, just think about yourself. I mean, we are surrounded by software. Everything we do nowadays is run with software. We have software in our computers, of course, in our smartphones, in the projectors, in the fridge, in the oven. We have software everywhere. And the demand for software is also rising. I mean, with this Internet of Things, we can think everything run by software. Okay? And the problem is that much of this software has a poor design. Okay, and is getting worse and worse and worse because of the reasons that we have just explained. Okay. So the result is that we are always in a perpetual software crisis. So software that are never delivered, many different reasons. Software that are delivered but they never been used. Software that are delivered late and over budget, and almost all of them require modification after the release and before they can be used. Okay, that make the maintenance phase very important. Okay, so usually maintenance phase is a long term, whereas the development phase is a short term. So you can develop for 3 months and maintain the software for years. Okay. There are some, we had some meetings with some partners here at the university, and some of them are still using software developed in the 80s in Turbo Pascal. I don't know if you even know what is Turbo Pascal. It's a very old programming language, but this software is still in use because changing that software is much more costly for the companies that maintain that software. They have data, they have services, other pieces of software that interact with this legacy system, and so on and so forth. Then, so maintenance is very important, as we will see later on. So the nature of software makes software well, difficult to deal with, but also the different types of software. For example, we have custom software, so software that has been made for a specific customer. So a customer comes to you and say, okay, I need a software that provides me these functionalities. Okay. Typically, this software is built in-house, okay, from the company itself. Many, for example, bank systems have been developed inside the bank or by means of some consultancy company. There is a generic software, which is the software that is sold on open market. It's also called commercial off-the-shelf software. Nowadays, you can download it, but when this term has been coined, you must go to the shop and pick the CD-ROM or floppy disk from the shelf. That's why the name. And there is embedded software. Nowadays, it's very important for these cyber physical systems, Internet of Things system, and so on and so forth, where the software is embedded in the hardware. Okay, it's built in the hardware, and that's very hard to change because you need to interact with the hardware itself. And then there are real-time software, so software that should react immediately. Okay, and they are usually used in a safety-critical system, for example, for running a manufacturing system or railways, airplanes, and so on and so forth. Okay, then safety is a very important concern for this type of system. Okay, then you wouldn't like to have a buggy software running on the flight that you are taking. Okay. That would be very, very bad. And we know that last year something happened because of this, for the plane that crashed because of buggy software. We have data processing software, which is usually used to run the business, for analyzing orders, for analyzing how much time you need to process the orders and to deliver the shipments and so on and so forth. And in this type of software, accuracy and security are very important. Just think about Amazon. How much important the security is for Amazon, where you store your credit cards data, and that's. And then there are some software that has hold these aspects together, and then it's quite important to understand the type of software, its nature, in order to understand what's the effort and what type of quality we can expect from the software that we are going to build. And that's why it's important to learn about software engineering. Okay, so I'm a software engineer. Then for me, software engineering is very important. Okay, it's not the silver bullet. Okay, we cannot solve everything with software engineering, but it's important to understand the routines and the activities within the software engineering best practice. So, but what is software engineering? You might already had a course or maybe a couple of courses about software engineering, but I want to stress again the importance of this discipline and the why it's so important. So there are many different definitions about software engineering. I personally like this one, that defines software engineering as the process of solving customers' problems by systematic development and evolution. That's very important, evolution of large, high-quality software system, of course, taking into account the cost, time, and other constraints. And these are the keywords that we are going effectively, okay, among themselves and with the customer. Okay, only interacting with the customer we can really understand what he wants and then what is the problem that we need to solve. How to do that? By applying systematic development and evolution techniques. Okay, that's which is provided by the software engineering, and that's what we will discuss during the course. Okay, so we need to apply well understood techniques because we already know they works. Okay, so design patterns, architecture, performance engineering techniques, requirement engineering techniques, and so on and so forth. There are many well-accepted practices that have been standardized by EEE or ISO that we will take into account, okay, in order to during the course. And as most development work is evolution, then we will also talk about legacy system and how to refactor or re-engineer legacy systems. Okay, legacy systems are everywhere. Also, this whole computer here is a legacy system. Okay, it's running Windows 7, I guess. Then it can be considered as a legacy system because it's old, because we have old software running on this PC. Okay, but I mean it's here. We can use it. We should keep using it, and then we need to deal with this type of systems. Large, high-quality software system. That's what we want to produce. We need software engineering techniques because usually this type of system, which are very large, it's very hard to understand. Okay, if you are alone, then that's why this is a collective effort. I mean, huge software means many different people working on it in teams, for example, and that's in fact it's a teamwork. Usually, it's a teamwork, and the teamwork should be coordinated. In order to do that, we need some best practices to follow. We can follow a waterfall process, or it can be agile development process, whatever we like, but it must be disciplined, okay, and applied systematically. The key challenge here, and that's something that we will discuss during this course, is how to divide the work, okay? Usually if you have a big problem, so a big problem is very hard to solve as a big problem. So the idea is to split the big problem in a set of small problems, and then to provide these small problems to different teams. And then every different team can work in isolation on the small problem, okay? Create a solution for the small problem, and then put together all the different solutions that solve the big problem. Okay, this is called the divide and conquer approach. Okay, then we will discuss this during the course. Usually this divide and conquer approach is driven by software architecture, and then we will discuss what is a software architecture and how to make the software architecture for software, and then how to use this architecture to split the problem in small problems. Okay, so the end of this process should be a product with sufficient quality. Okay, if we can provide quality, so the customer is happy. And if the customer is happy, we also are happy because we get money. Okay, easy. that's our job as a software developer. Make the customer happy. And then finally, we also mention cost, time, and other constraints. So the main reason is that resources are not infinite. Okay, we have few or many developers, but still a fixed number. Okay, we can hire other developers, but this means extra costs. Okay, and then the final objective is that the benefit should overweigh the cost. I mean, if producing a piece of software costs me $1 million and then I sell it for $100,000, I mean, that's not a good deal. Okay, so we need to make sure that the benefit overweight the final cost for the. But that's business stuff. That's why we will not talk too much about this, but we must be aware that there are some constraints in the software development. And remember that out there are many competitors, and usually competitors do exactly our job faster, cheaper, and maybe better. So we really need to fight against them. Okay. Most of the problems that we mentioned before that put us in a software crisis, where the software have not been released or have been released buggy, is that because there have been inaccurate estimates for cost and times. Okay, that's very important. So project managers are really important in a software development process, because they really need to understand what is the exact effort and cost for producing the software that we want. Okay. So, and that's why we want to apply software engineering practice. Okay, and here we will talk about design. Okay, and usually a software engineer design artifacts. Okay, not only code but artifacts. And when we talk about artifacts, we talk about documentation as well. Documentation is very important. Okay, its quality is also due to the documentation, not only because of the functionalities which are coded in the software. Okay, and then we want to apply software engineers practices in the programming, in the design, in testing, validation and verification, planning, analysis, development. All of them, all these activities should be run by means, according to best practices. Okay, and then we will dig into some of them. But first of all, we need to understand what is quality. Okay, so I mean, I already mentioned more than once this very important word. But what is quality essentially? In order to understand what is quality, we need first to introduce the different stakeholders, okay, for the software. Okay, usually a software has users. Okay, so those that will use the software every day to make their job. But software has also customers, which is the one who pay for this software. Okay, it can be a bank, okay, which is paying for creating a banking system that will be used by desktop tellers at the bank, for example. Okay, so the tellers are the users, the bank is the customer. But there are also developers, okay, us that need to make the software. Then we are stakeholders for the software. There are the development managers, okay, who run the process. Sometimes all these roles are fulfilled by the same person. Okay, for example, if you make your own startup, okay, then you can create the software for your own at the beginning and then sell it to other users. But at the beginning, you are the manager, the developer, the customer, and also the end user. So we have different customers, and usually each of them has a different perspective on the software, okay, and then has a different perspective on what quality is. Let's use a joke here to explain the concept. So sometimes, I mean, we have well, sometimes we always have a customer, and the customer has a need. Okay, so the customer go to the software house and try to explain his problem. As we will see later on, the description made by the customer is always fuzzy. They never know exactly what they want. Yeah, I would like to have a software providing this functionality in this way, but I'm not really sure because that's a new stuff for us, and so on and so forth. They never know what exactly they want. Okay, even because usually they are not expert in software. I mean, they are expert in their own application domain. They have no idea about software. And then on the other side, there is the project leader that try to understand what the customer is explaining, okay, and put on paper some requirements. Okay, the guys told me that he needs this type of functionality, but the project manager is not an expert of the domain. So he has his own understanding of what is needed by the bank, for example. Okay, he doesn't know exactly the domain and what are the problems within the domain. And then here it comes the developer, or the analyst, sorry, that starting from the project leader notes, try to analyze the software and make an early design of the software. And there we have the programmer, okay, that reads, try to understand what has been analyzed and code the software. Okay, and then finally we have the businessman that wants to sell the software and then has no clue about real problems, about code, about design, about the process. So his job is to selling, okay, is to sell software, and then of course always try to sell you a castle instead of an apartment. Okay. Then the problems within this line usually occurs because of different motivation. First of all, there's no documentation within this process, okay, these interactions. The customer try to explain himself in natural language to the project leader that takes notes, and then try to explain in natural language to the analyst what he understood from the customer, and so on and so forth. As we will see during this course, and that's why we want to use UML, for example, is because documentation shouldn't be in natural language. It should be in a formal language. So, I mean, if I have a UML diagram, okay, UML diagram cannot be misunderstood. Okay, well, it can, but it's more difficult than misunderstanding the natural language. At the end of the process, usually this is what will be put in operation, okay, with respect to the goal for the development. Okay, we start thinking about many different features. Okay, how to put all the features together, but then at the end, what we release, it's a subset of the real feature that we need. But of course, we worked a lot, and then we need to build the customer. So, I mean, we spent 2 years of development, and then the customer has to pay for this. And finally, yeah, that's the support after the release, the maintenance. Usually software is released and then we start a new project, but that's not correct. I mean, if we sell software to our customer, then we need to provide support. And as I said before, maintenance is the biggest part for the software development. And finally, that's what the customer really needed. Okay, so there was a misunderstanding at the beginning of the chain, and then we screwed up through the process. Then we really need to first understand exactly what the customer wants, and then use a good communication by means of documents through the process. So we talk about quality. So as like beauty, also the quality is in the eye of the beholder. So each of us has a different perspective on things surrounding us. Okay, for me, this remote can be very, very nice, but for you, maybe it's different. We might have a different view on every single object. That's why it's very important to understand what quality is and have some metrics so that we can measure the quality. I mean, if we cannot measure the quality, we cannot understand if we are doing well or not. So what is quality for the customer? Okay, so the customer wants to solve his problem and want to solve his problem with an acceptable cost because he wants to save money and want to save resources, but he wants to see his problem solved. Okay, that's his primary perspective. Okay, does the software solve my problem? Yes or no? And how much does it cost to solve my problem? And then we have the user, so the one that will use this software, and he also has some perspective. Okay, for a user, usually a software is high quality if it's easy to learn, if it is efficient to use. I mean, I need to make a query on the database, but if I need to wait half an hour to get an answer, then the efficiency of the software is not very good, and then the user is unhappy because he needs to wait for getting an answer. Okay, so usually the user uses the software as a support for his job. Okay, if the software does not help him to make the job, then okay, it's not inefficient. It's not efficient, and the user is not happy. But we also mentioned the developer. So also the developer has a perspective on the software, and then the developer is happy if the software is very easy to design. Okay, I can save time and stress. It's easy to maintain and easy to reuse its parts. I mean, that's very important. If I can make part for a software and reuse this part in the next project, I'm happy because I save time and then I save money. And then that's the development manager. I mean, he's happy if he can sell more. Selling more means that you can sell the same software to many different customers. So then I build it once and then I sell it many times. For example, I make the software for a bank, and a specific bank, and then I can sell the same software to many different banks. Okay, that means I will get much more money. Okay, and then of course you want to please the customers. I mean, if the customers are happy, then also the manager is happy. Yeah, of course, while containing the cost for both the development and the maintenance. So different perspectives. So how can we hold them together in order to have a clear understanding of what is the quality? So that's why we introduce some quality attributes, okay, that we're going to use in order to measure the quality of the software. Usability, for measuring how much happy the user can be when using the software, okay? And that is will measure how fast this user can learn about the software and get their job done. Then we have the efficiency, okay? Does the software waste resources such as CPU time, memory, or space on your hard drive, and so on and so forth, okay? So the more CPU your software is using, the more powerful, more powerful should be the machine that will run the software, okay? I mean, if you need 16 gigabytes of RAM to run your software, then you need to buy machines that are able to run this software. Okay, then we must take this efficiency into account. Reliability, that's very important. So how many errors you get from the software? I mean, if you using you're using a software and the software is crashing every 5 minutes, oh, that's awful. Okay, so you don't want to restart from scratch your work every 5 minutes because the software is keep crashing all the time. Then we have maintainability. Okay, how much easy is to change the software after the release for fixing the bugs or adding new functionalities. And how much reusable is the software or parts of this software, okay? So you don't have to reprogram or reinvent the wheel every time you need the same functionalities. Many different attributes, and it's very worth to notice that some of these attributes might clash each other, okay, might conflict each other. So usually when you try to increase the efficiency, you reduce the maintainability or reusability of the software. And then we will discuss this later in the course. But in order to improve the maintainability and the reusability, you should make the software more general. Okay? So the more general is a functionality, the more reusable is such functionality in different projects. Okay? For example, a database for user management functionality. You have user management functionality where you have login. You can sign in your application, put the login, password, and then you have some information about the users, address, and so on and so forth. Okay, the more general is this functionality, so the easier is to use this functionality in different domains. If you make it really specific for one domain, for example, for the university, and then you start putting attributes for the users, like, I don't know, your identification number at the university, or what type of exams you are following in the university, then the most difficult is to reuse this functionality in a different domain, okay, where you don't have exams or you don't have identity number and so on and so forth. Okay, so the more general is the functionality, the more reusable. But if it's general, most of the time it's not efficient, because in order to be efficient, it should be optimized. In order to be optimized, it should be really specific, okay, for the purpose you are addressing. Also, increasing the usability can reduce the efficiency, because in order to increase the usability, maybe you can put more functionalities, or you can put a lot of user interface. Well, you can make a better user interface, okay, by means of graphics or layout and so on and so forth. But all of this has a cost, and the cost could reduce the efficiency, maybe because you need more power to process the user interface than you need to process the data. Okay, then improving the user interface could reduce the efficiency. If you have a fancy web page with a lot of images and a lot of JavaScript running on the web page, this will decrease the efficiency of the page, because you need more time, for example, for loading all the information. Okay, but if you have plain HTML, okay, that's very, very quick. Okay. Then it's very important to set all the objectives for the quality at the beginning. Okay, don't think that quality is an add-on to the software. Okay, something that you can add later on in the process. Okay, let me first code the functionalities, and then later on I will think about the performance. No, it's not like that. So quality, such as performance, should be one of the first objectives, because it will affect all the design and the code. Okay, then otherwise, if you start coding and then you want to add performance at the end, in most of the cases you have to re-engineer all the application, because design has an impact on performances. Okay, and performances has an impact on the design. Then you really need to specify the objectives for the quality at the beginning of the process, not at the end of the process. Okay, and then once you have the objectives, then you design to achieve and meet the objectives. It's not the vice versa. Don't start from the end. Okay, and this avoids over-engineer. Okay, because otherwise you start doing stuff and then you recognize you did wrong, and then you have to restart from scratch or almost from scratch. So once you have all the objectives, then we also can think about optimization. Okay, as we said, some conflicts might some constraints or objectives might conflict each other. So when you have two different objectives to achieve, for example, security and efficiency, that are other two conflicting objectives, because I mean, the more you improve the security, the more you reduce the efficiency of the system. For example, because of encryption. So when you encrypt data, I mean, you take time, because encryption is quite hard and resource-consuming technique. Okay, so then you need to find out the trade-off. In order to find out trade-off between conflicting requirements, we need to optimize, okay, the development. There are two different types of criteria, okay, to approach this problem. The external quality criteria, okay, I mean, you observe the system from an external point of view. You typically is the user point of view, and try to understand what is the functionality provided by the software, what's the usability of this software, what's the efficiency and the reliability of software. Okay, how many errors we have within an hour, how much time does it take to get the response, how much easy is to use the software, Okay, hard the functionality, doing what the user is expecting, and so on and so forth. On the other side, we have internal quality criteria. Okay, so the system observed by the internal, let's say, point of view. Okay, is not just a black box, but it's a white box you can put your hands on as you are the developer. And this will characterize aspects of the design. Okay, that's where we will focus in this course. And this it's important because watching and analyzing the software from the internal point of view has also an impact on the external qualities. Okay, for example, maintainability. Okay, it's internal because I mean the user has no this glue. I mean it doesn't know nothing about maintainability. But improving the maintainability will usually also improve the reliability, okay? Because the easier it's to fix bugs, the faster is the release of a new version of the software, okay? And then the user will get a software which is less buggy. Okay, that's what happens every day. So, I mean, my smartphone, it's updating apps 3 times per day. I mean, this means that out there are developers that fix bugs every day, many times per day, and then continuously release new versions of the apps. Okay? Yeah, sure.
I thought maintainability belonged to external quality factors, and for example, internal quality criteria is like what's the size, or am I wrong?
Sorry, can you repeat that? I didn't hear.
Maintainability belong to the external quality criteria.
Yeah.
I thought so. And then
why?
What's the size of the because, well, if reliability also belongs to external quality criteria?
Because the reliability is I mean can be perceived by the users. I mean when you use the software and the software keeps crashing, okay, then for you as an end user is not reliable. Okay, I mean, writing your letter on Word, for example, and Word keep crashing every 5 minutes. Okay, that's a pain for the user. But the user has no clue about maintainability. So you, as a user, have you ever thought about how much it is to maintain the Office suite for the Microsoft developers?
Not really, but for example, if reliability, like, for example, not all bugs can occur. Some bugs will occur later.
Yeah, of course.
The user know that, like, if the program doesn't crash, that doesn't mean the program is reliable. So it can also be internal.
Yeah, sure. No, but okay. These are just example. Okay, so where is it? You're completely right for this. I mean, the reliability is both in the eyes of the user and in the eyes of the developer, because the developer need to test and check what's the reliability. But in the other case, maintainability, okay, why should it be external? I mean, the user has no clue about maintainability, so the software can also not be maintained at all for the user perspective.
That's what I thought. Like, for example, what's internal quality? You think internal so it means like it belongs to the program in itself. So what's the size of the program?
But that's another type of internal quality, and that's what we will discuss extensively in the third module. Okay, then we will see how to analyze the code and to understand what's the quality of the code in terms of we will check about coupling and other different metrics, okay, to understand the quality of the code itself. But this maintainability is more high level, okay, it's not so internal, okay, because maintainability also require, I mean, it's not only the code but also the organization of the software for example, the different modules and plugins, as you want to call them. Okay, it's it's still internal, but not so deep in the code. Okay, of course, it also it also affects the code, affects the maintainability. Okay, because it's all, the code which is done, bad way will affect the maintainability of the software as a whole. But yeah, we will discuss this in the third module when we will talk about metrics for analyzing the code itself and to understand how these metrics relate to this stuff. But here, it's more high level. Then we said there are two, we should distinguish between short-term and long-term quality objectives. Okay, so the long-term quality, short-term quality, sorry, is we need to ask ourselves, does the software that we are producing meet the customer's need now? Okay. Or more different, is the software that we are producing, for example, efficient enough for managing the volume of data that we have today? That's something that we need to understand. Okay, nowadays we have, let's think of a concrete example. If you have, you're running a bank, okay, then you have 1,000 customers. Okay, then you need to think, or are these functionalities that we are providing good for these 1,000 customers? And is the system able to manage in an efficient way this amount of customers today? But usually, as we say, the software is released today, but then it's been run for many different years. Then we also need to have a long-term perspective to our software. Okay, so how much maintainable is this software? If we want to add new functionalities next year, or what about future customer needs? Okay, so still change functionalities, add new functionalities, remove functionalities. Sometimes also removing some functionalities is important because of functionalities that no one is using, okay, but they are still there, making the software much more heavy and so on and so forth. Then sometimes it's better to cut out functionalities that are not used. Or scalability. So how can we scale, okay, the software with respect to the numbers of users? A couple of years ago, we had a guy from Stockholm here working at Spotify. Okay, so everybody knows Spotify, right? He was mentioning that they were moving from their own cloud to the Google Cloud because they were not able anymore to manage the number of users. Okay, so they grew so much that their server farm wasn't enough to manage all the users. And then they got rid of all their hardware and moved their software to they were moving the software to Google Cloud. I don't know if they already did it or still in the process of moving. But that's what he said. They're processing like 5 terabytes of logs every day. Okay? And they keep these logs in their database. So the database grow. It's huge. And they were not able to manage such a volume anymore because of the number of users that they have. And by migrating to their, so he was mentioning that migrating from their hardware to the new cloud is not easy. It was not easy. It was they were in the process, and then he was mentioning that the process was hard and quite long-term objective because you cannot move, copy-paste your code from one platform to another platform and think that everything will work well soon. Okay, so then scalability. it's important. It's something that we really need to take into account from the beginning. Okay, and this also depends of the target that we have for our software. Okay, then of course Spotify or Twitter, they have scalability as their main objective, I guess. But some other software do not have this issue at all. They might not have this issue at all. Even if so nowadays everything which is run on the cloud, and then this means that you do that because you want to be reachable as many users as possible. Then, as said before, we only have few slides left. We didn't have the break, but if you don't mind, we go through the end, so we finish earlier. Most of the projects that we will, or you as a developer, you will work on are evolutionary or maintenance project. Okay, and most of the time these involve a legacy system. Okay, system that has been running since years. Already mentioned about this software made in Pascal that we found on the server on our customer. This type of software might be corrective, okay, fixing bugs, defects. So there's bugs, and then you as a developer should fix it. But that's quite difficult because first you need to understand the project done years ago by someone else. Okay, the original software was done by someone. Then there have been other developers in between the origin guy and you that made corrective project themselves and then modified the software. Then you need to understand the original software plus all the modification that occurred over time. It's quite difficult. There might be adaptive projects. Okay, for example, changing the system in response to changes in other systems. Okay, you change your operating system from Windows 95 to Windows 10. Okay, it's huge. It's a huge jump. Okay, and then you need a new software that was not running on the previous operating system, and then because of this change, you need to adapt all your software. Because you change database from Oracle to MySQL, for example, and then still change database is not just removing a part and replace this part with another one. You need to modify your software, but also because the rules and the regulations are changed. I mean the world, okay, 10 years ago was different. We had different rules and different regulations. And so the software should follow the regulations. Okay, some of the some law that are today that were not 10 years ago. Just think about the GDPR rules at the European level that manage the privacy. Okay, so these rules they were not there 1 year ago, and then when they have been introduced, all the software houses had to rush and manage this modification and make their software compliant with the rules. Okay, that's very important. So the world evolves, and then we need to evolve the software accordingly. Or they might be enhancement projects. Okay, so adding new features for new users that have a new or different needs with respect to the old ones. And finally, we might have re-engineering or perfective projects. Okay, so this means changing the system internally so that you can improve it. Okay, for example, you can improve the design. So improving the design, you can improve the maintainability of the software, for example. Okay. We will also talk about these things during the third module, where we will talk about how to re-engineer and refactor or re-architecting an old software. Okay, we will analyze the software, try to understand what's the quality for this software, and try to re-engineer it in order to improve the quality. Yeah, so in order to do all of this, okay, we have software engineering practices. That's what we will discuss in this course. We'll start from requirement and specification. That's very important. If we don't have the requirements, we don't have the problem. If we don't have the problem, we have nothing to solve, and then it means nothing to design. Okay, as we say, design is a problem-solving activity. So, and first thing is requirement and specification, and that's why next week we start with the requirement engineering module. Okay, where we will understand how to make a domain analysis in order to understand the background. Okay, I mean, if we are creating a software for a bank system, I mean, we shouldn't be expert of the bank system, but we should have some ideas about the concepts that are particular for that domain. Then we need to define the problem and narrow down the scope of the system. Okay, don't think we can save the world. We can only save a small part of the world, and we have to focus on that small part that we want to address. Then we need to gather the requirements, obtaining as much possible input from as many resources as possible. For example, interviewing end users or interviewing customers, using scenarios, as we will see, in order to elicit the requirements for the application. And then we also need to analyze these requirements and organize these requirements into a document, okay, that can be used later on in the design phase. And then specify. That's very important. We need specification for the requirements. So stating the requirements in natural language is not good enough, because natural language can be misunderstood. Then we need formal language, or semi-formal, as we will use UML. UML is a semi-formal language, in order to specify our requirements, okay, in a way that is will not misunderstood by the designers. Then, once we have the problem state, then we can start working on the solution. Okay? And then we can start working on how these requirements should be implemented. Okay? And this is the objective of the design. So how to implement, how to solve the problems that are stated in the requirements specification document. Okay? And for this purpose, we need to engineer the system. It means decide what should be in hardware and what should be in software, okay? And in together, okay? For example, you say, okay, I need an app, okay? But an app, or what type of platform you want to develop an app for iOS or Android or something else? Why? Okay? Why you want to make this choice? What this choice will bring to you? Okay? In terms of I don't know. Number of users that you can reach, in order of type of functionality that you can provide to the users. Then the software architecture, how we split the system into subsystems, okay, so that we can approach the system into a divide and conquer process. And how this subsystem will interact each other, okay, once they will be developed. Okay, so if we split the application in many different distributed applications, then these distributed applications need to interact each other. How? By means of network, by means of memory sharing, by means of a database, okay, because we share the data between two applications, but use the database as a central point of synchronization. There are many different ways on how to split the application, how to put this subsystem into cooperation. And then we will detail about this. Then once we have this subsystem, we need to design every single subsystems, okay? Since the subsystem will be implemented in isolation, hopefully, okay? That would be very nice. If we are able to develop every single subsystem in isolation, okay, this means that this will provide us a lot of good things, okay, that we will discuss later on. But there are many techniques, okay, that you might dip into the next years, okay, on how to make this. Then there is a user interface design and design of database, so how data and user interface. We will not touch these two issues in this course, okay? We stop in the design, this architecture and design phase, okay? We will not talk about the user interface. That's media technology stuff. And how to put all of this together? We're gonna use and make an extensive use of models, okay? Models will be our language, okay? We will use models for modeling the use case and elicit the set of features that the system needs to provide. We will use models for defining the structure and then the software architecture for the system that we want to implement. And we will also use models for specifying the dynamic and behavior of the system. So how this subsystem that we introduced, they interact each other, how the data flow from one subsystem to another subsystem, okay? And then we will use UML diagrams for all of this, okay? From the requirements down to the performance analysis, down to the design and implementation. And then there is the programming, okay? Programming is not, I mean, we will talk about code. In particular, we will talk about Java code, but programming is not something that we will go through this course, okay? There will be a 2DV 609, okay, following course where we will approach programming issues. And then it's orthogonal to all the activities, this quality assurance, okay? And this encompasses all the processes, okay? And then we will talk about quality everywhere, in the requirements, in the design, in the architecture, okay? So quality, it's very important thing. And then finally, there is the deployment. That's also something that we will not touch in the course, but it's part of the, well, software engineering process. Usually it's the last activity. I mean, you finalize your development and then you put the software into operation, okay? So distribute and install the software and any other component that allows you to run the system. And then after that, there is the maintenance, okay? So keep working on the software, maintain the software, fix the bugs, and then redeploy. But this is DevOps stuff, okay? You have a course for DevOps process. Do you have any question? That's last slide for today. Next week, lecture will be held in Kalmar. And so I don't know if you want to move there or watch the lecture on streaming. Okay. Questions? Okay, that's all then. Let me see if we have questions on Slack. So I can answer. Okay. Thank you very much. That's all.